Hello everyone. It's about 10 a.m. Thursday, April the 21st, 2016, and this is DelrayVAWeather.com. I haven't done a video in a while, but we're going to do a video about the research I've been doing on thunderstorms and severe thunderstorms in the Alexandria, Virginia, and Washington Reagan National Airport area. And what I've done over the last couple months, I've downloaded the KDCA observational data set going back to 1972. It's a daily data set, so it has data for every single day during that period. And it has a variety of data fields, some of which have been used through part of the period, and then they stopped using that particular field, and then new fields were added. So unfortunately, this large data set back to 72 is not real consistent. And what you see up on the screen is a listing of the various fields that are most related to thunderstorms and severe thunderstorms. Unfortunately, there are only a few that really are useful for determining if there was severe thunderstorm conditions at Washington Reagan National Airport on a particular day. And the two fields that are, I think, most useful are asterisks there. There are the field WSF5, which is the 5-second average wind speed. That was used from about February 1st, 1998 to date, and the data is in tens of meters per second, so you have to do a conversion to get it to miles per hour. And the other field is the WTO3 field, which is the thunder field. It's a flag field, which means it's either going to have a value of 1 or 0. And if it's 1, then there was thunder detected at Reagan National on that day. But there's really, I have been unable to find any clear definition of what constitutes the thunder at Reagan National Airport, at least with respect to how far away the thunder may have been. Actually, from the physics, thunder really can't be heard beyond about 10 miles. It varies with some conditions, but temperature and heavy rain, various things like that. But as a general rule, you won't hear any thunder past 10 miles. So I'm assuming that when that flag is set, it means that at Reagan National Airport they heard thunder, which would mean that the storm producing the thunder was within 10 miles of Reagan National. And KDCA is the designation for the weather station at National Airport, and I'll be using KDCA throughout this video. Okay, if you want a little more detail, you can pause the video and read the text on the screen. But that's all I'm going to say about the defects in the data set. Okay, there's another data set that is available, which you can search by zip code. It's a daily data set that goes back to 2006, and it talks about it indicates whether there was a severe thunderstorm warning for that given zip code. So what I did is I took the KDCA data set and identified the days in which there was a wind speed of 258, or actually 25.8 meters per second wind gusts, which computes out to the wind gust that constitutes a severe thunderstorm, and indication that there was thunder in the area of KDCA. And so between 2006 and 2015, there were 7 days at KDCA where they recorded a severe thunderstorm condition like that. And 2 of those 7 actually did correlate pretty well with what I'm sure you all remember. One was the derecho on June the 29th, 2012. And the other one was the Alexandria microburst that did so much damage in the city of August 5th, 2010. However, if you look at those 7, only 3 of those 7 were actually covered by a National Weather Service severe thunderstorm warning prior to the observed event. 1 of the 7 had a thunderstorm warning that was actually 29 minutes late from the time at which the KDCA recorded the severe conditions. And 3 others had no severe thunderstorm warnings. Why did that occur? Well, here's my theory. The way we are situated here in Alexandria and Northern Virginia, we are on the lee side of a mountain range, the Appalachian Mountain Range. And so conceivably what is happening here is that you may have a line of severe thunderstorms coming in from the west. They hit the mountains, and as they go over the mountains, many times that line of thunderstorms weaken. So by the time they're on the east side of the Appalachian Range, they no longer have the necessary conditions to qualify them as severe thunderstorms. As they move closer to the DC area, some of those weakened storms strengthen. So potentially, if you have a storm that's moving at conceivably 60 miles an hour or 50 miles an hour towards us, it can strengthen in around 15 to 20 minutes from a non-severe thunderstorm to a severe thunderstorm. So within that period of time, the Weather Service has a very short window to identify that storm now is at severe conditions and issue the thunderstorm warning. And I think that's one of the reasons why you saw the one that was late. In fact, anecdotally, I know that many of the severe thunderstorm warnings that I've seen often are issued after for Alexandria, are issued after the storm. Either the storm is at Alexandria or is just passing Alexandria. So I think the reason why you have such a low percentage of severe weather that actually is warned from the National Weather Service is the nature of the topography in this area. I suspect if you did the same analysis for on the Maryland side of the Potomac, you'd find that the amount of severe thunderstorm warnings that are in place when there's a severe thunderstorm probably have a better average because they're strengthening just before they cross the Potomac, and that gives the Weather Service enough time to at least warn the Maryland side of the severe weather. Okay, let's take a look at this next slide. Okay, just again, this repeats. The 3 had advance warning, 1 was late, 3 had no Weather Service warning. But the interesting thing here is that between 2006 and 2015, the Weather Service issued 58 severe thunderstorms warnings for Alexandria, Virginia. That's the total for that period. Since we only had only 3 of those actually matched the observation, it means that in only 5% of the severe thunderstorm warnings do we actually observe severe conditions. And that, as a general rule, often the Weather Service will issue a severe thunderstorm warning if they feel that it's likely to occur. Not necessarily it's occurring at the at the present time. And so often that projected increase in the strength of the storms never materialize, and in the vast majority we never have that specific criteria of a severe thunderstorm, which is like more than 56 mile an hour wind gusts. But potentially you could have 50 mile an hour wind gusts. That still will do a considerable damage, but it wouldn't actually meet the criteria that the Weather Service would issue a warning of. And I should say also there's another criterion that's hail size. It's you can have an inch of hail or larger, or that 56 mile an hour wind speed to qualify as a severe thunderstorm. Unfortunately, the KDCA dataset really doesn't give a good indication. It indicates whether there was hail, but it doesn't indicate the size of the hail. So for this discussion, I haven't even considered those storms that produce hail but less wind. So, okay, that's where we are right here. But there's some other interesting things I'd like to show you. This shows by year the number of thunderstorms that KDCA indicated, and that again they have a flag. It's either thunderstorm or not thunderstorm. It says nothing about severe thunderstorms on this chart. And you'll notice that there have been a couple of years that we've had unusually high amounts of thunderstorms through the year. And this is actually for the summer months. It's only the June, July, August period that we're looking at. There are thunderstorms in the spring and some later in the year. But for this graph, we're only looking at summer thunderstorms. 2003 holds the record. That year we had 31 thunderstorms in the summertime. So that was kind of interesting. Again, I tried to take all this data and correlate it to El Nino, La Nina, and various other indicators like that to see if they could be predicted. We could predict the severity of a given year's summer and spring. I found no correlation, very, very low correlation. There's maybe a weak correlation with that you get more thunderstorms in a La Nina year, but it's really not very strong and really can't statistically say it's going to be more thunderstorms or less thunderstorms. Okay, this is the indication of the median thunderstorms between the months, by month, between 1998 and 2015. And this is kind of interesting because it sort of goes against the popular belief that you get more thunderstorms in July. In this data set, it shows that actually June is the month of most thunderstorms. And over that period, there was 132 thunderstorms over that from 1998 to 2015, where in July there was only 119. So it does indicate that the June is the month for thunderstorms. Both June and July are definitely thunderstorm months. But a higher amount seemed to occur in June. Okay, now what I did, the thing is, with 7 events that technically met the criteria for for a severe thunderstorm, that's a really small amount. So what I did, instead of taking the explicit severe thunderstorm criteria that the Weather Service uses, I looked at how many thunderstorm events had winds more than 47 miles per hour. That's considered a force 9 gale. So when you reach 47 miles per hour or up to I think it's 55 mile an hour. That's force 9. And above the 59 is force 10, and that definitely is a criteria for a severe thunderstorm. But if we look at all those events that had at least wind speeds, 5-second wind speeds of 47 miles per hour, it shows that again in June you have thunderstorms that have potentially have the most wind behind them. And in this case, there were 14 events in June over that period that had those strong winds, where in July you only had 7. So it's like twice as many thunderstorms in June that potentially have damaging winds compared to July. And after July, it really drops off. Okay, well, I also looked at the percentage of severe versus thunderstorms. So how many thunderstorms had at least 47 miles an hour winds, and what was the percentage of the total number of thunderstorms by month? And this is kind of interesting. Nearly 20% of thunderstorms in November have winds of 47 miles per hour or above. And I suspect the reason for this, even though the total number of thunderstorms is fairly low, the percentage that are actually have wind behind them is pretty high, is because of hurricanes. Often in the area of October and November, we have the best chance of seeing hurricanes come inland and affect the DC area. And so I suspect that that's what's going on with this high percentage. But if you look at the other months, with the possible exception of June, the percentage of severe versus regular thunderstorms is fairly low. It's less than 10%, between 5 and 10% chance that a given thunderstorm would become severe. Okay, I'm going to leave it there. If you have any questions, just give me a tweet at PatPend, that's PATPEND, and I'll try and answer them. Thanks a lot.